All right, guys, we are on 11.4 matrix algebra. So for this section, we have few definitions here that we have to get through before we start the examples. All right. Okie dokie. Two matrices A and B are said to be equal. Written. This feels super fat, doesn't it? There you go. Written. A equals B, provide that A and B, capital means matrix, all right, have the same number of rows and columns. And each entry A sub I j in matrix A, which is now we're using capital letter, is equal to the corresponding B ij in B. Okay, so the lowercase with the subscript, those are each entry, and big capital A and B represents matrix themselves. 2. Sum A plus B. You can only add the matrices if they are the same size. By adding Aij plus Bij, by adding the entries. Now difference is the same thing. We can only add them. Okay, so only if they are the same size, by not adding, obviously, by subtracting the entries, Aij minus Bij. Commutative property of matrix addition. So if we have A plus B, we can compute B plus A. Now, associative property of matrix addition. So we have A plus B first, and then plus C. In addition, that would be the same thing if we were to go and add matrix B and C first and then add A. As you can see, these are not the same for subtraction. Okay, zero matrix. So if we have matrix A plus zero matrix, which is the same thing as zero matrix plus A, which equals just simply matrix A. So the properties for matrix C's addition, they're exactly the same as just the number properties. Property of a scalar multiplication. So we got a few things going on here. So if you have a scalar, let's call it K. A scalar just means any number. And we have another scalar, let's call it H. And we want to multiply it to matrix A. Okay. That should be the same thing as if we were to take two scalars, H and K, multiply it first, and then multiply it to A. Now, property number 2, if we were to do scalar H plus scalar K first and then multiply to A, that is the same thing as if we were to distribute the scalars and then add the matrices. And we have one more. If we have K times matrix A plus matrix B, that would be the same thing as if we were to take the scalar K times matrix A and then add to scalar K times matrix B. Let's pinch that in. 8. Row vector R, okay, is a 1 by n matrix such as this. Here's matrix R. It's a 1 row, so 1 row has entry R1, second entry R2 because it's only one row, dot, 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 R sub n. So one row. If you see big capital R, just one row. Now this is kind of similar to column vector C. It's an n by 1 matrix. So if you see a big capital C, it means one column. So entry 1, entry 2, dot, 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 entry however many, okay, one column. The product of R times C, so remember R is one row, C is one column. That means we take your R matrix, okay, and we multiply that to your one column matrix. The result, students, okay, the result is going to be R1 C1 plus R2 C2 dot 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 plus plus here plus Rn plus Cn. I'm out of space. Now this will come up to be just one number. Okay, so the answer, final answer after you add up all of those will give us one number and only one answer. 11. Product of matrix A times B can only be performed, and this is super important, can only be performed if the number of columns in matrix A equals the number of rows in matrix B. All right, so again, that's super important, okay? The number of columns in A must be exactly the same as the number of rows in B. If that's not true, you may not multiply two matrices. 12, associative property of matrix multiplication, which is very similar to addition earlier. So if we multiply matrix A, B first, then C will be the same thing as if we were multiply B, C first, and then times A. Distributive property, if we have matrix A times matrix B plus C first, that's the same thing as if we would distribute and then add. Now, matrix multiplication is not commutative, so that's why we don't have one for multiplication. We just have two more. Identity property. If A is an M by N, so that's row by column matrix, then I subscript M, so identity matrix times some random matrix A will just give us a matrix A, where I matrix subscript M is called the identity matrix. And one more, diagonal entries or the main diagonal. So diagonal entries, or aka the main diagonal for an n by n. So if you have an n by n, now this is a square matrix, okay? So square matrix. The entries located in row I, column I, where your I must be bigger than or equal to 1 and less than or equal to n. Okay, so remember I is your location. Okay, so it's talking about diagonal entries or the main diagonal. It's the right in the middle of the matrix. All right, students. Example 1 from 11.4. Okay, use the following matrices to evaluate the given expression. Now, as you can see, I'm doing a lot in each example. In your book, they may separate these things out. They may just do 2 times matrix A, or they just do A matrix A plus matrix B. No, but if I teach you everything at once, then you can go back and do the easier version of it, okay? So letter A says, I want to have 2, which is your constant or scalar, times matrix A, then 4 times matrix B, and then add it all together. So the first thing we want to start is 2 times A, and then over here, that means 2 times A, and then I need space, so I'm gonna write these out a little bit further apart. So what does 2 times A mean? Well, 2 times the entire matrix. That means every single entry in the matrix is twice as big. Okay, so 2 times 0 is still 0. 2 times 3 is now 6. 2 times negative 5 is now negative 10. 2 times 1 is now 2. 2 times 2 is now 4. And 2 times 6 is 12. So that's what you do when you multiply a matrix by a scalar. Now, 4 times B is very much the same. 4 times 4 is 16. 4 times 1 is 4. 4 times 0 is 0. 4 times negative 2 is negative 8. 4 times negative 3 is 12. 4 times negative 2, again, is negative 8. Then we are going to add these two together. When I add these two together, I'm going to have a 2 rows by 3 columns, okay? All you're doing when you're adding is you're adding the same location. So 0 plus 16 is 16. Then we're going to take 6 plus 4 is now 10. Then we're going to take negative 10 plus 0 is negative 10. Then we're going to take 2 plus negative 8 is negative 6. We're going to use 4 plus 12. Ooh, that's fat. Okay, let's make it skinnier. Okay. 4 plus 12 is now 16. And the last entry, oops, let's use gray. There you go. Oh, what happened? Okay. The last one is going to be 12 plus negative 8 is now positive 4. So that's a final answer. Let's box it up. And that's how you multiply a scalar, and that's how you add 2 matrices. And again, remember, you can only add 2 matrices if they have the same number of rows and same number of columns. Okay? B. B says, I need to multiply the 2 matrices. Okay? And once I'm done multiplying, I take the answer and I add 5 times this identity matrix. Remember, the identity matrix I subscript 3, that's the size, so 3 by 3. And remember, matrix I, that means there's just ones in the diagonals. Okay, so let's start. I'm going to need a lot of space, so I'm going to box that up so I can organize myself. Okay. First, let's do C times A. So C times A is matrix C, which is this guy over here. I'm just going to copy that down. 4, 1, 6, 2, negative 2, and 3. Times matrix A, which is this guy over here on the left. 0, 3, negative 5, 1, 2, and 6. Okay, that's what it means. Then add 5 times identity matrix of a 3 by 3. Well, 5 is a scalar. Identity matrix, let me give you what it means. Identity matrix of subscript 3 is a 3 by 3 with the ones in the diagonals and 0 everywhere else. That's the identity matrix subscript 3. A 3 in the bottom denotes a size, a 3 by 3. Okay, so if you multiply 5 by the identity matrix, okay, that's what this is right here. Oh, actually, can I just write 5 in the diagonals now, just to save myself some space? Okay, so 5 here, 0, 0, 0, 5, 0, 0, 0, 5. So that's what happens when you multiply 5 to the identity matrix. Next. What's going to take a lot of work would be the C times A, okay? All right, here we go. And I'm going to write everything out very slowly. I would need a ginormous matrix for doing the work of C times A. And so when you multiply matrices, you're going to take row number 1, and then you're going to multiply column number 1 of the second matrix. Okay, so what do I mean by that? So row 1, column 1. So we're going to take 4 times 0 plus 1 times 2. That's what I mean to multiply row 1, column 1. Then same thing, I'm going to take row 1, different color, row 1, column 2. So I'm going to take 4, ready, column 2 is now 3, okay, plus 1 times negative 5. I'm sorry, 1 times, that's row, column 3, 1 times 2. Okay, so you got, this is column number 2. And again, I'm still multiplying to row 1. And the next one is row 1 times column 3. So we're going to take 4 times, so now this is row 1, column 3, times negative 5 plus 1 times 6. Okay, we will work out the basic math later, but I want to write everything out so you are very clear. Next, we are going to try to multiply row 2, column 1. So row 2, column 1. Row 2 is this guy right here, and column 1 is this. So we're going to do 6 times 0 plus 2 times 1. Then we're going to do row 2, column 2, which is this right here, and that. Okay, so 6 times 3 plus 2 times 2. Then we are going to do row 2, column 3. Again, back to row 2. This is my last column. So 6 times negative 5 plus 2 times 6. Okay, so that, we have to do this every time we multiply two matrices. So we're going to do one entry at a time. Then we are going to go back to row 3, column 1. Row 3 is, let me erase a bunch of this stuff because I cover everything up. Okay, row 3 is now this guy, negative 2 times 3, and column 1, oops, what did I say, Dealing? Negative 2, I'm sorry, times 0 plus 3 times 1. Okay, then we are going to be working with row 3, column 2. So again, row 3 is this one, column 2 is back to this one. So negative 2 times 3 plus 3 times positive 2. And the last one, we are going to take again row 3 and column 3. So we're going to do negative 2 times negative 5 plus 3 times 6. Okay, so that's what we do every time we multiply two matrices. Now let's work out the basic math. Are you ready? Okay, so this right here, all of that, it should be a, okay, let me tell you what size you're going to have. Okay, when you multiply a 3, let's talk about the C matrix. Let's pick a color. What have I not used? Did I use? How about green? Okay, so matrix C is, if you look at this right here, 3 rows. Okay, matrix C has 3 rows by 2 columns. Okay, now matrix A has 2 rows by 3 columns. Okay, this is your trick. If these two inner values are the same, that means you are able to multiply. Again, you write down the sides. Okay, if the two inner values are the same, then you can multiply. Now the two outer values, let's pick a highlighter that you can see. The two outer values, like here, that will tell you the sides that your final answer is going to be on. So because it's a 3 and a 3 on the outside, that means your remaining answer will be a 3 by 3 matrix. Oops. Okay, so that's a little secret right there. All right, let's work out the basic math. 4 times 0 plus 1 times 4 times 0 plus 1 times 2. Oh, why 1 times 2? Oops. Sorry, this is supposed to be a 1 times 1. Okay. Oh, that should be, that's confusing to you guys. Okay. sorry, because this is a 1 times 1. So this is row 1, column 1. So 4 times 0, 1 times 1. Ooh, almost missed that one. So 4 times 0 is 0. 1 times 1 is 1. So that's going to be 1. Then 4 times 3, which is 12. 12 plus 2 is going to be 14. So that is 14. 4 times negative 5 is negative 20 plus 6 is now going to be a negative 14. So that's my first row. All right, next is going to be 0 plus 2, so that's 2. 6 times 3 is 18 plus 4, that's going to be 22. 6 times negative 5 is negative 30. Negative 30 plus 2 times 6, that's 12, so that's going to be a negative 18. Next is negative 2 times 0 is 0. 0 plus 3 times 1 is 3. Negative 2 times 3 is negative 6 plus 6 is 0. Then negative 2 times negative 5 is 10. 10 plus 18 is now 28. So that's the product of C times A. Remember, we also have to add 5i. But 5i, we already found the answer. It was 5, 0, 0, 0, 5, 0, 0, 0, 5. My final answer is, because these two are the same, identical in size, I can just add them straight up. Final answer of this entire problem is 1 plus 5 is 6, 14, negative 14 because of those two zeros. Then 2 plus 0 is 2. 22 plus 5 is now 27, and negative 18. 3 plus 0 is 3. 0 plus 0, 0. 28 plus 5 is now 33. So class, your final answer for example B is that. This is example 2 in 11.4. This one says find the product. Remember the previous example, if you remember, we did on B, we did a lot, right? We multiplied two matrices and then we add another one. So if this one is a simpler version of example 1B, it says find the product. That means first I need to check to see if you can multiply these. To check that, you need to find the size of each matrix. The size of the first matrix is a 3 rows by a 2 column. The size of the second matrix is a 2 rows by a 3 column. Remember, I taught you this before if you were listening. If you have the inner values are the same, that means you can multiply, okay? Now the outer values is what the product is going to be. So the final answer would be a 3 by 3, okay? All right, here we go. First, I have to write a big matrix because I want to write down everything for you. So the first one we're going to do is we are going to do this over here, okay? We're going to do row 1. I'm going to write it out. Row 1, column 1. Are you ready? Row 1 is 1 times column 1 is 2 plus negative 1 times 3. That's row 1, column 1. Oh, I might need to expand this a little bit. Then row 1, column 2. So it's going to be 1 times 8 plus negative 1 times 6. Okay, I need to expand this a little bit. And all the way over there. Okay. Then next I need to do row 1, column 3. So 1 times negative 1 plus negative 1 times 0. So the more you do it, the quicker you get. And when you get so good, you don't even have to do this out. You can just do all the basic math in your head. Next, I want to do row 2, column 1. So row 2 is negative 3 times 2 plus negative 1. Row 2, I'm sorry, that means I need to do row 2 is this guy. That means it's 2 times column 1 times 3. Okay? It's easy to make mistake if there's so many numbers, right? Then the next one I want to do is row 2, column 2. So again, this is column 2. So we're going to do negative 3 times 8 plus 2 times 6. And the next one I want to do is row 2, column 3. This is column 3 right here. So we're going to do negative 3 times negative 1 plus 2 times 0. So those are all of the ones that I want to multiply. Now one more. Next, row 3, column 1. Row 3, let me erase what I had before. Here's row 3. Column 1's that guy. So 0 times 2 plus 5 times 3. And next is going to be row 3, column 2. 4, I know that much, okay? Row 3 again is 0 times column 2, so that's 8 plus 5 times 6. And we have one more. Let's use green. Row 3, column 3. So 1, 2, plus 1, and 2. So row 3 is going to be 0 times -1 plus 5 times 0. Okay, let's do the basic math, add it all up. So we know that it's going to be a 3 by 3. So now that I can do that, there you go. 1 times 2 is 2. 2 plus -3 is now going to be -1. 1 times 8 minus 6, that's 2. -1 plus any 0 number is now a -1. -6 and a +6, so that's 0. -3 times 8 plus 12, so that's going to be a -12. +3 plus 0 is +3. 0 plus 15 is 15. 0 plus 30 is 30. And 0 plus 0 is 0. So your final answer is that. And that's how you multiply, baby.